Okay, so for this one, how many of you got $414? Okay. What else would you get for anything different? What's that? Okay, it's still a little bit off. After 8% tax, you pay $450. You want to know what the price is before tax?
I have an 89.
89. Oh, sorry. No, that's 8. So we have to find what that was before the tax. The problem was we have the price before tax plus the tax, and we get the price after tax. So what we're getting here, we're looking at percents on one side and dollars on the other. What we're getting here, the $450, is the price after tax. 8%, of course, goes on the percent side for the tax, and we always know the 100% is the beginning amount. So 100% is the price before tax, which means by adding 100 plus 8, the price after tax is 108%. Now, we don't want the amount of the tax. We want the price before tax. We want that number. So I can ignore this row here. To find that number, I can just cross multiply and divide. 100 times 450 divided by 108 is $416.67. The way most people approach that is they jump in and they find 8% to 450, which is $36, and they subtract it. The problem is the 8% does not apply to the 450. The 8% applies to whatever matches up with 100%. That's the 416.67. Let's look at a couple of more of those before we move on to our new stuff for tonight. Let's say that after a 15% discount, you pay $510. What was the full price? In other words, what was the price before the discount? I'm going to give you guys a minute or so to see if you can find that one in your notes. So again here, it's not the 15% we're working with. What percent are we really working with? What's that? 85, exactly. So we could go ahead and just do 85%. The 510 is the amount after discount, which is what the 85% stands for. And the full price would be the 100%. So we can cross multiply and divide. 100 times 510 divided by 85. Which is $600. So the full price would have been $600. Or, I like to use the table. We would add full price minus the discount. Again, the words don't matter as long as you know what they mean. Equals the amount paid. And we just put in the numbers. The amount paid was $510. Discount was 15. Since this is a discount, we're subtracting. So it's 100 minus 15 is 85. And what we're looking for is this number right there, the dollar amount of the full price. So we don't need the middle row. So 100 times 510 divided by 85. Notice the same calculation we did over here. I'm just doing it within the table rather than in a proportion. The table helps me get it organized. Any questions? You look confused over there. You okay? You don't have to worry about the table if you can, as long as you can figure out how to do it this way. Just the table for me helps keep it organized, so I make sure I've got things matched up. Because over here, the tough part is figuring out that the 85 matches up with the 510. The key is they both represent the price after the discount.
When the discount you subtract, and when it's not.
If it's an increase, you add. If it's a decrease, you subtract. Yeah. We did talk briefly a couple classes ago about something called the rate method of percents. And in the rate method, you turn the percent into a decimal, and then you had to either multiply or divide by that rate. And I had mentioned that there are some applications where the rate method is preferred. And there are. When we are going to start out with a whole amount and use the percent times that percent or rate to get a portion of that amount. If we're going to do that over and over, and we know we're always going from the whole amount to a portion, using the rate is the simplest way to go about it. One application of this might be commission. Normally, this would be if you're working in a sales field, you could collect commission. There are some industrial applications. Some would go by a dollar of production. If your production is worth a certain dollar amount, you get a percentage of that dollar amount for each shift. But mostly it is in sales. So for example, let's say you're going to get, your commission is going to be 12% of sales. You could go ahead, let's say you have I gotta finish that. Let's say you have a week where sales is $4,200. We could just go ahead and find 12%. 12 out of 100 equals blank out of 4,200. And if we cross multiply and divide here, 12 times 4,200 divided by 100 is going to give us $504 as your commission. But if we're going to have to do this every week, rather than setting up this proportion and cross multiplying every week, it'd be easier to use a rate. So it would simply be our sales, 4,200 times that rate. 12% as a decimal would be 0.12. And that would give us $504. So if we're going to get 9% commission, and you have your sales for the week of $8,750. Let's find our commission. $8,750 times what? 0.09. $787.50 is your commission. Now, not all commissions are quite that simple. This is what is referred to as a straight commission. And given a straight commission, that's all you get paid is your commission off sales. You have a week where you make no sales, you get no commission, period. There was a crackdown not too long ago based on minimum wage, where there were some people that were working in sales positions. If they weren't very good at selling, their commission was not equaling out to minimum wage if they figured it out by an hour. So they got in trouble with that. So one of the things they did was they came up with a wage plus or a salary plus. Let's look at wage plus first. A wage plus might be they're going to give you $8 an hour plus 4% commission. Now notice that percent is much lower, but you're already getting a base wage. The base wage is usually really close to minimum wage, just enough to make sure that they know they're going to meet the minimum wage requirements and not get in trouble. And then the commission would be your bonus to make the job more worthwhile. So let's say you have a week where you work 32 hours and make sales of $6,500. Your pay, of course, comes in two parts. 32 hours times $8 an hour is $256. Your $6,500 times a rate of 0.04 is going to be what, $260? We add those together, we get a total of $516 for the week. What do you think? Not so bad? Okay, on the other side, the salary plus, it might just be $300 per week salary plus, well, we'll go 5% commission. So you have a week where your sales are $7,100. So we don't have to do hours because we don't, this is salary, not hourly. But we do have to do our commission. So 7,100 sales times what? .05, good. Which is going to give us $355. Now, of course, we do still have to add our 300 base salary to get $655 total pay for the week. Any questions? Normally, when they do a wage plus or a salary plus like that, they don't give a full commission. We're going to look at salary plus because the wage plus is a little more complicated than I want to deal with right now. Let's say that they offer you $350 per week salary plus 7% on sales over $5,000. What they're saying there is they're going to give you that $350 a week. But for that $350, they're expecting you to make some sales. So they're not going to start your commission at the first dollar of sales. They're going to start your commission once you go over, in this case, $5,000. So let's say you have a week where your sales are $7,900. To calculate your commission, you first have to subtract that $5,000 from the $7,900. You are only going to get commission on $2,900 of those sales. So now we're going to multiply that by 0.07, which is what, $203, I believe. Perfect, thanks. And then we've got the $350 a week that we're going to add to that. We get $553 for gross pay for the week. So that would be a salary plus, or sometimes called a base plus model. Some places use what's called a graduated scale. A graduated commission, you get bonuses for going over a certain amount. So let's say your scale is 0 to 5,000 is 9%. Over 5,000 is 12% commission. So if you have a week where your sales are $8,300, well, that $8,300 is going to get split into two categories. We have the first 5,000, and then how much is over 5,000? $3,300. Good. That first 5,000 gets paid at 9%, so times 0.09, which is going to be $450. The next $3,300 gets paid at 12%, so 0.12. So $396. So that works out to be $846 total pay for the week, gross pay for the week. Any questions? So let's say your commission is 11%. Oops, I don't know where the dollar sign came from. 11%. And that week you have sales $7,700. But you have returns of $1,200. How do you figure the commission on that? You're going to subtract. 7,700 minus 1,200 is 6,500. Your commission gets paid off of your net sales. That's what that's called, the net sales. Your sales minus any returns or errors or anything like that. So then that gets multiplied by 11%, or a rate of 0.11, which is $715. I want to show you guys one more example, then we're going to get off of commissions here. This one I like to show you just because it used to be a big deal, and it still does happen a little bit. Let's say you get into a sales position, you get offered a sales position, and they tell you they'll give you 12% commission with a guaranteed $800 per week draw. And they explain it to you as you're going to get $800 a week, period, no matter what. If at least $800 a week. If you get more sales, you might get more commission than that. But you'll never get less than $800 a week. But it's not an $800 salary, it's $800 draw. So to define what that means, set up a little table for us. Let's say that in week 1, you have sales of $4,800. Your commission off that is going to be 4,800 times 0.12. $576 is your commission. How much are you going to get paid? What's your paycheck going to be? $800 are guaranteeing you, right? No. They guaranteed you $800, but you only earned $576. So what that means is the rest of that money goes against what's called a draw. The difference between $800 and $576 was $224. You only earned $576, but they paid you $800. That was $224 more than what you earned. Well, what does that draw mean? Well, I'll show you as we go through this. Let's say in week 2, things start to pick up, and you sell $6,100 worth. So your commission, $6,100 times 0.12 is $732. What are you going to get paid? $800. Guaranteed $800 a week draw. Well, again, you were paid more than you earned. How much more? Well, if we subtract 800 minus 732, that's $68, right? 224 plus 68 is $292. You have a draw balance of $292. So now in the next week, let's say you kind of hit your stride. and you sell, I don't do 7,000 on it, it's a little closer. 6,800. So your commission, 6,800 times 12, 12%, 0.12, is $816. What are you going to get paid? Only $8. But you made more than $800. Why don't you get the full 816? $16 goes to that draw. It's basically, the draw is basically a floating loan. It's a rotating line of credit. You subtracted it because that was, you earned more. So basically you're paying back that $16. Until you have, let's say now you get week 4, you sell 7,500. So now your 12% of that is going to be 0.12. I'm blacking out on that. What is that? $900? Yeah, so you're still going to get paid $800. Pay back $100. Now at $176. Once you've got a zero balance on your draw, then you'll get more than $800 if your commissions are more than $800. So you'd have to have a big week. I'll show you here. So let's say you get a $10,000 week. $10,000 week. So times your 12%, that's a $1,200 commission. Well, you still owe $176 on your draw. So you got to zero that out. You are going to get paid $1,024. That's your $1,200 commission minus what you owed on your draw. Which, that's fine if it, 5-6 weeks you hit your stride and you start doing well and eventually you pay it off and now you're making bigger checks. You start to get bigger than that $800 check. But what happens if you suck at sales? You get 3-4 months into this and you're not doing well, you don't like your job and you want to quit, and the second you decide to quit, guess what happens? That is due. And there were people that were getting in to these jobs and 5 or 6 months down the road, it just wasn't a good fit. And they went to quit and they'd owe $8,000, $10,000 on that draw. There are some regulations that limit this, but it does still happen to some extent. Like I said, they are required to give you at least what's considered a minimum wage. Okay, so enough talk about commissions. I want to talk now about interest. Many of you are going to go on to a business math class or math with business applications. And one of the big topics in there is interest. So we're going to start out talking about something called simple interest. Simple interest is just the way it sounds. It is the simplest way to calculate interest. Simple interest is only calculated in one of two cases. You get to the end of the term, of course you got to calculate the interest then, or if there's an action on the account. And by action I mean you make a payment or you make a withdrawal. They figure in the interest at that time. Usually they figure the interest in before the action is made. So the way simple interest is figured, it goes by this formula. I is equal P times R times T, where I is the dollar amount of the interest, P is the principal, that's the amount that you start with, R is a rate, again that's a percent as a decimal, T is time in years. So let's say you invest $4,000 at 8% for 3 years. Your amount of interest is going to be, principal is $4,000. That's the money you started with. Rate, 8% or 0.08. Your time is 3 years, so 3. 4,000 times 0.08 times 3 is 960. So your interest is $960. How much will you have at the end of the 3 years? Well, you will have your $4,000 you started with, plus your $960 in interest. $4,960. Now, simple interest generally is not used for things that are 3 years long. It's usually used for shorter term things. Now, however, with that said, if you take out a home mortgage is figured off simple interest. If you take out a car loan, an auto loan is figured off of simple interest. Why do they figure off simple interest there when a mortgage is either 15 or 30 years and a car loan is anywhere from 3 to 8 years? How can they get away with just using simple interest? Well, because what do you have to do every month? Make a payment. Right? Every time you make a payment, they're going to figure out the interest. So let's say that you buy a $23,000 car. Your terms are, let's say you get one of these really popular good car loans now, you get 4%. Actually, you get down to like 1.99 if you got really good credit rating. Let's say you get 4%. Let's say your monthly payment $450, which is not far off, by the way. So how much do you owe after your first monthly payment? Well, your interest is going to be your $23,000 times your rate of 0.04. Your time is 1 month. But we said time was always in years. So 1 month is 1/12 of a year. So how do we punch that in? It is 23,000 times 0.04 times 1 divided by 12. $76.67 is the amount of interest. So what happens is before they accept your payment of $450 and apply it to the account, they figure out the interest. So you got your $23,000 plus $76.67. So your balance before you make the payment is $23,076.67. So then they accept your payment of $450 to get you to $22,626.67. That is your balance after the payment. This is actually pretty typical, by the way, on a car that expensive. You are paying between $70 and $80 a month in interest. So we said that simple interest only applies to shorter term loans or things that they know there's going to be an action every month, like a car loan or a mortgage, so they can figure in the interest. That's one of the reasons why a lot of banks have rules against paying ahead. Like I know there's certain banks in the area that won't let you pay more than 2 months ahead. if you keep making payments, they just apply it to the principal. Because if you get paid, like let's say you get paid 6 months ahead and then you don't make any payments for 6 months, no interest gets added in for 6 months. At the end of the 6 months, they add in this huge chunk of interest, but it doesn't get built up. They don't get any compounding on it. So anyway, let's look at something longer than that short period of time again. And we're going to talk about how they do the interest there. It's called compound interest. Compound interest, they're going to figure out the interest every so often, and they're going to add it into the account, whether there's an action on it or not. And now then, in the next period of time, when they figure out the interest, well, that old interest is part of the balance, so you're going to get interest on top of the interest. That's where the word compounding comes from. So let's look at that first example of $4,000 at 4%. But this time I'm going to say compounded quarterly for 3 years. So instead of figuring out the interest for the whole 3 years, I have to figure out the interest 1 quarter at a time. So in quarter 1, my interest is $4,000 times a rate of 0.04 times 1/4 of a year. It was 4%, wasn't it? Or was it 8%? Oops, it was 8%. Sorry, let's do the 8%. This is 8%, so we have to change that. Sorry about that. So $4,000 at 8% compounded quarterly for 3 years. So that's $4,000 times 0.08 for 8% times 1/4, which is going to be $80 in interest. So that means to start quarter 2, we have 4,000 plus 80. So that's $4,080. My interest is going to be based off of that. So 0.08 times 1/4 again. This is $81.60. So you can see we get more interest already because of the compounding. So we're going to add that to the balance of $4,800. It's $4,161.60 is what we start quarter 3 with. And we would have to go through 0.08 times 1/4. How many times am I going to have to do this to get through 3 years? 12 times. Yeah, quarterly means 4 times a year. For 3 years, 4 times 3 would be 12 times. I don't feel like doing this 12 times. So let's look for a shortcut. Each month, or each quarter, how much interest is being added? Well, it's 0.08 times 1/4. 0.08 times 1/4 is 0.02. So what that means is every quarter, they're figuring in 2% interest. That makes sense. 8% for the year. 8 divided by 4 is 2% per quarter. That makes sense. Just like we were doing before, you have the beginning of the quarter plus the interest gets you the end of the quarter. At the beginning of the quarter, if we call that beginning amount 100%, our interest is 2%. That means at the end of the quarter, you have 102% of what you started with. So to get from the beginning of the quarter to the ending balance, which starts the next quarter, we just have to find 102%. So if we were to take our 4,000 times 102% becomes what is our rate? As a decimal, it's 1.02. 4,000 times 1.02 is 4,080. That was our balance at the end of the first period, and what we started the second period with. And then we can take that times 1.02 again, 102%. 4,161.60. How many times am I going to multiply by 1.02? Still 12 times, right? So basically I'm taking 4,000, I'm multiplying by 1.02 12 times. In math, do we have a shortcut for multiplying by the same number over and over again? Yeah, it is a power of 12. So if I take $4,000 times 1.02 to the power of 12, I get $5,070.97. $5,072.97. Notice before we had 4,960, so we got like $112 more, $113 almost more with the compound interest. So we did simple interest. So compound interest makes a difference. Now this was a relatively short period of time, over 3 years. Compound interest really makes a difference if we go over a longer period of time. Just a little survey of the room. How many of you in here are under 25? Okay. A few of you are close to it at least. Let's say you get out of school. You start working that first job. We're going to give you guys a couple years to get out of school. You're 27 years old. Right now, minimum age to draw Social Security to retire, you could draw partial at like 62, but to draw full Social Security is 67 years old. And actually, by the time I get up there, it's supposed to be more than that. By the time you guys get up there, it's probably going to be 69 or 70. But let's go with 67. How many years is that right now? That's 40 years down the road. Now, right now you're in school. You're probably living a little bit cheaper. Maybe you have roommates, living with friends, family, whatever. Probably driving your older car instead of buying a new one. A lot of people, once they get out of school, they get that first good job and they're making good money. One of the first things I want to do is I want to buy a nicer car, maybe move into a better place, maybe buy some toys even. But what if you stay living the way you are, living pretty cheaply, and just save money? How much money do you think you could save up to put away in that first year? Considerable amount? 3, 4, 5,000? Depends. But if you have kids, it's more difficult. You're right. They seem to suck the money out of us. Let's just, for argument, say $5,000. If you're leaving it in there for 40 years, how much do you think you can earn in interest per year? Now, a lot of people say, well, 2 or 3% right now. Well, that's talking about bank accounts. For retirement savings, usually I would go to a professional investment planner and have them do something a little bit better than bank accounts and certificates of deposit. Right now, if you work in the market, if you do it wisely, the average annual gain over any 40-year period in our stock market has been between 12 and 13%. Those even include periods, 40-year periods that include the Great Depression in the 1920s and 30s, and 40-year periods that include the big crash of 2009. Well, because in like 2001, we had years where we gained 40% in the stock market or more. So having years where you lose 30%, it balances out. The average annual gain has been between 12 and 13%. So if you go to a professional planner, I would say you'd have no problem making 10%, kind of conservative. I'd usually figure like 12%, but we'll stay on the 10% side. So that means at the end of the year, you would have 100% plus 10%, or 110%. Does that make sense? At the end of the year, you have your original 100% plus your 10% interest. So that's 110% of what you started with. So to put that in a rate, that's 1.10. So every year you end up with 110% of what you started with. We're going to do that for 40 years. We're only going to compound once a year, no quarterly or anything like that. Now, without punching this in a calculator, can anybody guess as to what this number is going to come out to be? 5,000 times 1.1 to the power of 40. 50,000, 100,000, 27 million. 226,296. $220,000. By the way, that goes up to 12%. A lot of you think, oh, a couple, half a percent or 1% doesn't make that big of a difference. At 12%, that's 465,000, or about double, more than double what we have here. But even at 10%, 226,000 is pretty good, right? That's if you started at 27. But what if you wait till you get out of school and you say, you know what, I'm going to have some fun with my money. I'm going to buy some toys. I want a new car. I want to move into a nicer place. Maybe I got to get away from family or friends or whatever. And I'm going to have some fun for a few years. And at 37, I'm going to start saving for retirement. So now let's say you still put away that same $5,000. And let's say you can still get 10% on it. But now it's only going to sit there for 30 years. How much is that going to be worth? Anybody want to guess before I hit equals? What's that? 150? 87,247. It's a little bit more than a third of what you would have had if you started 10 years earlier. Let's say you wait just 5 years more. 42. I'm 43, so I'm going to figure that as my age. Now it's only going to sit there for 25 years. This is going to make me cry, I know. $54,174. About a fifth of what you would have had if you'd have started at 27 instead of waiting until you're 42. For those of you that are younger than that, it works, even if you go smaller than that, it works the same way. If you go start at 22 instead of 27, I'll punch it in for you. For 45 years instead of 40, that'll jump up to 364,000. So the younger you start, the better. In fact, let me show you this. I know we're closing in on break. We'll go just a little bit long on our first hour here today. I'll make this a little bit bigger for you. I'm starting at the age of 21 just to have a starting point. We'll go up to, where'd you go? $67. Let's put away that $5,000 a year. Still at 10% interest. So put away that $5,000 every year, starting at 21. Anybody want to guess? Over $4 million, $4.3 million. Even if you start at 27, you're still over 2.4 million. Let's stick with this 27 amount here. I'm going to show you something based on that. what I want to show you is this. So this person here starts at 27 and puts away $5,000 a year. And they go till they're 35, actually 34, and they say, you know what? From here on out, I've saved all I want to save for retirement. I'm going to take every penny I make and I'm going to play with it. Now I'm going to have all the toys I want to. I'm going to go on vacations or whatever. Not going to save any more. So we're going to put zeros in all these all the way up to 67. Anybody want to guess how much they have? Still 1.3 million. This person over here takes the opposite side and says, you know what? I want to play when I'm young. So I'm not going to invest anything. I'm going to play with my money for that first, 8 years? So I'm going to play with my money for that first 8 years. Then at 35, I'll start saving for retirement. So this person saved for 8 years and then just let it sit there. This person started at 35, so they saved for literally 32 or 33 years. Who do you think's ahead? Yeah, it's not even close. This guy's over $200,000 ahead. Because you're getting the interest on a bigger number to start with. Yeah, by the time this guy even starts contributing, this guy's got $62,000 in there. Let's back it up a year. So this person only saves for 7 years, and this person starts at 34 and goes for 33 or 34 years. Now they're pretty close to even. That first 7 or 8 years of your life, when you start working and can save money, is worth more than the next 30 to 35 years of your life. I'm not going to tell you what to do with your money, but go ahead. Somebody's starting to make a comment. Yeah, I know. How old?
Well, I mean, you're 67.
Well, you can't do much with the money. What good's it? I always thought it should be the opposite way. You should retire when you're like 21 and then go to work at like 35 and work till you die. Retire when you're young enough to enjoy it. Okay, I'll stop preaching. Anybody have any questions or you want me to plug any numbers in here so they can look at anything? Okay. Something to think about. Now, I'm not an investment planner, so if it's something you're interested in, go to a financial planner of some sort and talk to them. But I have to put it out there so you've seen it, so I feel my obligation to you guys is met. I've shown it to you so you know about it. Let's take our break. We're a few minutes late, so let's start lecturing again at 4:33. In the second hour, that's all of our new material. In the second hour tonight, we are going to review for the test, which is next Tuesday.